Okay, the first day of notes on 6-6 was on trapezoids. Remember, on trapezoids we had one pair of parallel lines. Okay, those were called bases, and then we had the others were called legs. Okay, and then we also talked a lot on that first day on isosceles trapezoids, where both legs were congruent. This second part, I wish the author had split this up into two sections, but he put it all in one. But this second part is on kites, and we're also going to talk about the hierarchy of polygons. I'm going to give you like a Venn diagram and then also kind of a little chart to show how all these are tied together. Okay, so first thing, most of you have probably flown a kite, but to talk about a kite in geometry terms, a kite is still a quadrilateral. Okay, so it's got four sides with exactly two distinct pair of adjacent congruent sides. So it's still got four sides, and if you will draw this, so this side is congruent to this side, and label them that way. And then this side is congruent to this side, so AD is congruent to CD. Okay? But AD is not congruent to AB. They are not the same length. AB is congruent to BC. Okay? So you draw a kite. It's a quadrilateral with exactly two distinct pairs of adjacent congruent sides. Okay, so make sure you draw the picture. And I labeled on this, with the point where the diagonals intersect, I labeled that point N. Okay, then they talk about the diagonal BD, so that would be this one. It separates the kite into two congruent triangles. Okay, and if you look here for a minute, this separates the kite. Here's one triangle, this large triangle, BAD, and BCD. Those two triangles are congruent. This one, this large one, BAD, and this one. Okay, so the diagonal BD separates the kite into two congruent triangles. And you might want to go ahead and label them. It's like triangle BAD is congruent to triangle. And remember, when you label those, it ought to be in the right order. BCD. Okay, those two triangles will be congruent. Okay, and then the diagonal AC. Okay, this diagonal coming through here separates the kite into two non-congruent triangles. So if you look at the top triangle up here, triangle ABC is not congruent to triangle ACD. They are not congruent. So like triangle ABC is not congruent to triangle ACD. They're not congruent. The diagonals do intersect at right angles. Okay, so when you mark this, you should mark a right angle. All four of these would be right angles, so they would be 90 degrees. So that would tell you what the other two angles of each triangle add up to 90. Okay. Okay, and this AN is congruent to CN. So you should mark it that way. Okay? AN is congruent to CN. But since it's a kite, okay, BN is not the same length as ND or DN. They are not the same length. This one is not the same length as this one. So they are not congruent. Okay? Okay. Then the author goes through theorem 6.25. Theorem 6.25 says if a quadrilateral is a kite, then the diagonals are perpendicular. Okay, and we already said that up above. When the diagonals intersect at right angles, they are perpendicular. Okay, so if a quadrilateral is a kite, then the diagonals are perpendicular. So you have 4 right angles in the middle. Okay, and then theorem 6.26. If a quadrilateral is a kite, then exactly one pair of opposite angles is congruent. Okay, and picture-wise, this is what that looks like. Okay, if you have a kite, okay, this angle is congruent to this angle. I also marked it up above on that picture. If you have this picture drawn, you could mark it here, and that's good enough. These 2 angles are congruent. Okay, that's theorem 6.26. If a quadrilateral is a kite, then exactly one pair of opposite angles is congruent. Is angle B congruent to angle D? No. No. Okay. Okay, now I want to go through a little Venn diagram, kind of tying some of these together. Okay. First, draw a rectangle. Draw a rectangle or a square. Okay. And label outside this ellipse. Label quadrilaterals. So that'd be all 4-sided figures. Okay, then draw an ellipse, a big ellipse. And inside that, label parallelograms. Okay, and then inside the ellipse, draw 2 more ellipses. Label one of those rhombi. Okay, and label the other one now. It's not in the intersection. In the intersection, you can go ahead and label that squares in here if you want to. The author labeled it out here, but you could go ahead and write it in there if you've got enough room. And out here would be rectangles. Rectangles right here. And then the intersection would be squares. Then outside that ellipse, I need you to put kites and trapezoids. Kites and trapezoids are still quadrilaterals, but they won't fit into parallelograms. Now, if you look at that drawing, if you look at that Venn diagram, if I said you have a square, is a square a rectangle? Yes. Is a square a rhombus? Yes. Is a square a parallelogram? Is it in that big ellipse? Yes. Is a square a quadrilateral? Yes. Okay. Now, if you take, if I give you a rhombus, is a rhombus a rectangle? Sometimes. Because if it was in that overlap, if it was right in here, wouldn't this rhombus be a rectangle? Yes. So it's not always, but sometimes. Is a rhombus a square? Sometimes. If I said, is a rhombus a parallelogram? Yes, always. Because it's inside that ellipse. Get the idea? Is a kite a parallelogram? No. Is a kite a quadrilateral? Yes. Get the idea? Is every parallelogram a rectangle? No. Is every rectangle a parallelogram? Yes. Okay? So that kind of ties all those together. That's one way to do that. Okay? Here's another drawing that kind of ties it all together. And I call this, and the author called it the hierarchy. Okay? Okay? Start all the way down at the bottom. Give yourself probably a half a page. Okay, on the hierarchy, spell that right. It's HIERARCHY. The hierarchy of polygons. Start all the way down at the bottom and put squares. Okay, and then an arrow going out of the squares. One arrow goes to rectangles. One arrow goes to rhombi. So even there I could say, is every square a rectangle? Could be a rhombi, right? Okay, and then come up a rectangle, go to parallelograms. Rhombi, go to parallelograms. Is every square a parallelogram? Yes. Okay, it will work its way up to a parallelogram. Okay, and then go from parallelogram, go up to quadrilaterals. That's a four-sided. And then from quadrilaterals, go up to polygons. Okay, and then also down at the bottom, start with isosceles trapezoids. And that's where two legs are congruent. And then from isosceles trapezoids to trapezoids, trapezoids to quadrilaterals, and then to polygons. Okay, and also a kite. A kite is a quadrilateral. Okay, so there's two drawings that should kind of help you, okay, on how all those quadrilaterals tie together.